All right, folks. Hello again. We are going to be doing section 1-2. We'll call it part B today because it is the second part where we're going to talk about composition of functions. Remember, yesterday we did operations on functions. Today is composition of functions. And we're going to have inverse of functions next, just to keep these a little bit shorter. We may end up doing a couple in a day, but they won't be one long lesson. So, composition of functions. Now, we've done similar things that you didn't call composition of functions. If, for example, you had a problem, say in Algebra 1, that said you needed to figure out how much paint to buy to paint a room, and you were given the size of the walls and all that kind of stuff. Well, you first had to find maybe the square foot of the walls. That was its own function. It was an area function. So you found how much square footage you were covering with paint. And then you had to look at the paint and say, how much does 1 gallon cover of the wall? So I have one function that tells me how many square feet I have to cover. And then I have a second function. When I get that result, I put that in, and it tells me into another function, and it tells me how many cans of paint, how many gallons of paint I'm going to have to buy. So that idea of taking the result of one function and putting it into a second function to get your final result, the one you were looking for. That's the idea of composition of functions. When we talk about it in terms of our terminology and our notation, it's like if you had an x, and when we say x, we're talking a member of the domain, right? An element of the domain that we take and we put it into a function. We'll call that function f. If we put it into that function, when it comes out, again with our new notation, it doesn't come out changed into a y. I mean, technically, if you have y as a function of x, it does. But what we want to think of it as is it comes out as f of x. All right, the function value at x. We put x in, we put it into the function f, it comes out as f of x. What composition does is one more step. It takes f of x as your input now into a second function, maybe called g. And what we get out of that is what would be g of f of x, where f of x is what we put in, g at the value of f of x is our final result. All right, now how your book will note this out, not just your book, but often another notation for g of f of x is this. All right, now the way I kind of read this is g, and I think of that as an O. It's not a dot like multiplication, it's an open circle. So g of, I think of it as, even if there wasn't an f there, g of f of x. All right, g of f of x. Don't look at this as multiplication of g times f of x, or g of x times f of x. This is g of f of x. It's composition. All right, you have to recognize that part of what you're going to learn this year is how to read math and to talk math and to understand the math speak that you've kind of been sheltered from, because you're going to need it when you get to calculus. There's no way around those words and those notations. So you want to be able to read this. It's going to be very important when you get into assessments that you're able to read that the proper way. Now, we could do it the other way. We could do x and plug it into, say, the function that we had called g, and we would get out g of x, right? Now, if we plug that into the function we called f, we would get out, I'm going to go down here a little bit, that would now be f of g of x, or f circle g of x, so f of g of x. So the one thing I want you to realize is these two numbers, or these two processes, could be vastly different. So don't assume that g of f of x is the same as f of g of x, because it rarely is. So you want to be careful about which one you're doing first. The order is important in this process, so I want to be very clear on that before we get started. All right, so we're going to dive in here, and I think the easiest way to see this is with examples, so we are going to do some. I'm going to give you some functions to work with first. All right, so let's create some functions. Let's use an f of x that is x squared plus 1. And let's create a g of x that is, let's call it 3x minus 2. All right, and finally, h of x, a third function, we'll call 2x minus 1. All right, so let's start with something basic. If you were asked to simplify or to find the result of this. Let's do this one. All right, so when you look at that, how do you say it? Think to yourself, what would you say for this? What I hope you're thinking is g of h of x. Now, to keep this clear in your head, what I usually suggest is if you're given this notation, I usually kind of write it immediately as this, g of h of x. That way, I can see that the first thing I have to do is this right here. I have to do h of x. All right? Another way to see that is this. I would write this way. G of, well, h of x was 2x minus 1, right? We know h of x is this. So I'm going to do g of 2x minus 1. Now this goes back to when we did the last chapter in our prereqs. We talked about doing g of a plus 1 or something of that sort. Same idea here. What we're saying is our input is going to be that 2x minus 1. Sorry, that should have been black. All right, the input is going to be 2x minus 1. So what we look at is g of this. This is going to go in wherever we see x in the function g. So right here is the only x in function g, right? So in this place, we are going to put 2x minus 1. So what is that going to look like? It's going to look like this. We're going to say 3 times our x value. I should have come down a little farther. Times our x value, which is 2x minus 1, then minus 2. Notice I use substitution with a with parentheses so I can see what I got to do. So looking at this, in order to simplify this, what would be next? Well, we got to look at order of operations. This parentheses has to be handled. It's got a 3 on the outside. So we're going to distribute the 3. So 3 times 2x is 6x. 3 times negative 1 is negative 3. And we still have that negative 2 left. So now, combining like terms, we would get 6x minus 5. Now, this is if we're trying to find g of h of x. Now, what if instead I had said, and let's just do this to the side, what if instead the problem had asked for g of h of 3? What could I have done? Well, what I could have done here is first found h of 3, because again, I'm going to do the inside first. I could have just done h of 3. h of 3 is 2 times 3 minus 1. That is 6 minus 1, which is 5. And then knowing that now, I would need to find g of 5. Do you see how this works? We did h of 3. h of 3 was 5. So I need g of h of 3. That's g of 5. All right, this is the more specific case of this rather than the general case with the x's. So g of 5, what do we do with g? Well, g told us to multiply everything that is our x by 3 and then subtract 2. So I'm going to do that here. I'm going to say 3 times my value of h of 3, which is 5. That's my new x. And then minus 2. So this would be 15 minus 2, or 13. Now, what I want you to look at here is if you look across and you see what's going on here, if I had done g of h of 3 directly here, and I just plugged 3 in here, we would have had 18 minus 5. Isn't that the same thing? So this gave us the general expression over here that we could plug any number into and get g of h of that number. This gave me specifically g of h of 3. So it shows that this is that general expression. If I had a bunch of numbers to plug into g of h of whatever, then I'd probably want the general expression and just keep plugging in the x. It's a lot quicker and easier, less chance of an error. So this is why we try to make composite functions every now and then, because this composite function leads us quickly to these type of solutions, instead of having to do one function process and then take the result and put that result in the second functional process. All right? So let's do another one. I want to get some experience here with you. All right, let's use those same functions, and let's do Let's say another example from the same functions. Let's do f of g of x. All right, f of g of x. So what does that look like? Well, again, I would write this first this way so I can see what I'm dealing with. That's my f of g of x, meaning I'm going to start with g of x. Okay? So g of x, what was g of x? G of x was 3x minus 2. So I'm doing f of 3x minus 2. All right, now what did f tell me to do? Because that's what I've got, my result for g of x is 3x minus 2. That's what g of x is. So what is f of that? Well, f said take any x and square it and then add 1. So I'm going to take my new x, my new input, square it, and add 1. Right? Because remember, if you don't want to go back, f of x was equal to x squared plus 1. G of x was equal to 3x minus 2. So you see where I'm getting this. We use g of x, that's this. We plugged it in for 3x as 3x minus 2, and then we use that to go into f. So we squared it and add 1. Now we're not done here because we don't have a fully simplified expression. So what we have to do next is go back here and finish this. 3x minus 2 squared. This is a major pothole that people will fall into, stumble through, whatever you want to call it, every time we do this. Be careful. Don't just take 3x and square it and 2 and square it. You can't be brain dead as you're going through this and just do like instinctual stuff. Do it as you know it should be done, and that's this. We're doing that. That's what 3x minus 2 squared are, these two things squared. So what you end up with is the first thing squared because they're both the same. So I would have 9x squared. Now look at outer and inner. Outer and inner, aren't they the same quantity? Aren't they both a negative 6x? So you just take twice that. So that's negative 12x. And then we have negative 2 times negative 2, that's a positive 4. This is the quicker way of doing 3x minus 2 squared. Just take this quantity, 3x, square it, multiply these two, negative 2 and 3x, make negative 6x, and double it. You get negative 12x. And then take negative 2 and square it, you get positive 4. And don't forget, you still had a plus 1 there. Okay, so now combining like terms, I get 9x squared minus 12x plus 5. And we have our result for f of g of x. Now, just to demonstrate, you look at what that is. Now, let's go ahead and do g of f of x. Remember I mentioned that these aren't always the same. Well, let's see how it works here. If we do instead g of f of x, let's see how this looks. All right, so now we're doing g of f of x. Right? Again, be able to read this notation. And our f of x was x squared plus 1. So I'm doing g of x squared plus 1. Well, what does g tell me to do? G tells me, again, just look back here, g tells me to take whatever x is, multiply it by 3, and subtract 2. Right? So, now I'm going to do that. I'm going to say, all right, if I'm doing this, I'm going to do 3 times whatever my x was. Now my input is now this, so I got to put that whole thing in there for x, and then subtract 2. Okay? So now we simplify. And again, you're going to hear us say, and now we simplify, probably about 2,000 times this year. And that may be an under-representation, maybe 5 times that. We're going to say it constantly because it's what we do every day in here. Again, just to remind you, you're heading to calculus. In calculus, being able to simplify a process or simplify an expression can mean the difference between 2 pages of work and 2 lines of work. So you really want to be able to do it to simplify your life, no pun intended, once you get to calc. So now we distribute this 3x squared, and 3 times 1 is a positive 3. Still have the minus 2, and that simplifies the 3x squared and plus 1. So you look at this result and compare it to the result up here, you see we've got 2 different expressions. One is f of g of x. Remember, this is f of, whoops, it was supposed to be an f of g of x. This is g of f of x. They give you different numbers. So the order is important, and it's important you're able to read which one do I do first. If you're looking at it this way, you do the one inside first. Looking at it this way, do the one inside first. That's how I always think of it. Don't ever start at the ends. All right? So again, this is one of those processes that you've got to get used to. You've got to play with it. You've got to practice it. You've got to get some experience with it so that you know how to kind of generate these things. You got to go slow. Do the proper thing. Here we didn't have to square with the input. Here we did, and it was a binomial. So you got to be careful with these things. And I strongly suggest, I can't make you write everything down, but I can tell you, the more you write down and the more you do this as a practice, what will happen is two things. In the beginning, I'm not going to lie to you. You've had people tell you, oh, this is much better for you, and give you no reason, and all you know is it makes your homework take longer. If you practice this at this level, because we have so many steps, in the past you could do like 2 steps in your head that you had for a problem and probably get it right and write it down, and that's no big deal. Our problems you're already seeing can sometimes be 4, 5, 6 steps. It's hard to keep track of that in your head, and it's even harder to do it correctly constantly. What you're going to find is if you start to write what I write, like this kind of thing, I kind of demonstrate what I think you should practice like. If you practice your homework in this way, what you're going to find is it may start out to take you a little bit longer in your homework. But within a very short time, I'm talking within a week, 2 weeks at the most, you're going to be flying through these problems faster than you ever did, and you're going to be getting more right. And there's a reason for that. You start to become a visual inspector as you're doing these. As you're writing things down, you're catching those errors that you don't catch mentally or visually in your head. And what's a secondary reason you're going to go faster is, have you ever done a problem in your head and you get halfway through it and you forget the number and you got to start over again? So you repeat the process again. That burns time. Here, if I made a mistake on the second line, I can just put a line through it and write a new second line. I don't waste time trying to generate from the beginning. Even better, if I'm on the 4th line in my head, I got to go all the way back to the beginning. If I'm the 4th line here and I write it down wrong, I can put a line through it and just go back to the 3rd line and start again. I can double check, okay, everything was right there, and go to the next thing. Again, what you'll find in a very short time is you'll do your homework faster and more correctly than you've ever done it. And what that translates into is better scores on quizzes, going faster. If you're one of those people that says, oh, I can do it in my homework, but one, I run out of time on quizzes, or I run out of time on tests, or I make a bunch of silly mistakes on quizzes and tests, these are problems that can be fixed by practicing your homework authentically. Write down this stuff, get faster and faster at your process. In the beginning, it's going to be slow and steady and correct. It starts to move faster and faster and faster. You'll start to find, if we ever get back in school together, especially if I'm working on the board with you, I can write a problem down and go through it faster than you can process it in your head. And you'll get to that same level. It's not just because I've been doing this for years. It's a skill that you can learn very quickly. So I really suggest you try to make your work look like what I show you here. Probably a little neater because I run through this and I'm still learning the tablet a little bit, but I think my writing's getting a little bit better. But again, authentic practice. Try to make it look like this. Use these steps. Use them as an outline. Use it as your go-to. And try to do it from memory. Try to go through this lesson, listen to it, look at it, get it kind of in your head, then go do problems. If you get stuck on that first problem, second problem, third problem, go through and finish it. Then come back to your notes and see if you did it right. If you didn't, make the corrections. And again, do it again on your own. Put the notes away. That's what we talk about with authentic practice. You're going to keep hearing this for the next few months because no matter how much I say it, there will be people that crash and burn on the first quiz that we do and will need to see and hear this again and again and again until they start making those adjustments. But trust me, very quickly here, you'll be on track and you'll be crushing this stuff. It gets easier and easier. Just follow along and trust and we'll get you there. All right, so that's part 2. And I'll see you back here for part 3 real soon. All right, have a great day.